Hello, everyone. Aviation history is filled with aircraft that promised revolutionary performance. Engineers drafted sleek shapes, powerful engines, and bold new combat roles. On paper, many of these machines appeared destined to dominate the skies. Yet the reality of flight often revealed hidden weaknesses. Structural flaws, unstable aerodynamics, unreliable engines, or flawed combat concepts turned ambitious designs into operational disappointments. Some aircraft entered combat only to suffer heavy losses. Others struggled through years of redesign. A few never progressed beyond the experimental stage. During the rapid expansion of military aviation in the 20th century, aircraft design often advanced faster than engineering experience. Governments demanded greater speed, longer range, and heavier firepower than existing technology could reliably provide. Designers experimented with new aerodynamics, unconventional layouts, and ambitious propulsion systems. Some ideas succeeded and shaped future generations of aircraft. Others exposed painful lessons about stability, maintenance, and survivability in combat. The result was a long list of aircraft that looked promising during development, but revealed serious flaws once tested in real operational conditions. The WorlBrewster F2A Buffalo entered service in 1939 as the United States Navy's first monoplane carrier fighter. On paper, the aircraft appeared modern and capable. It featured retractable landing gear, an enclosed cockpit, and relatively heavy armament for its time. Early prototypes demonstrated respectable speed and maneuverability. However, additional armor and equipment soon increased the aircraft's weight significantly. The engine power remained largely unchanged. As a result, performance steadily declined. Pilots reported sluggish handling and poor climb rates. During early Pacific War battles, the Buffalo struggled against more agile Japanese fighters. Its disappointing performance quickly ended its frontline role. The Blackburn Roc emerged from a British belief that turret fighters could dominate bomber interception missions. Introduced in 1939, the aircraft carried a powered turret with 4 machine guns mounted behind the cockpit. Designers eliminated forward-firing guns entirely. The turret was expected to provide flexible firing angles against enemy bombers. In practice, the heavy turret severely reduced the aircraft's speed and agility. The Roc became one of the slowest fighter aircraft in British service. Enemy fighters easily outpaced it. Operational use was brief and mostly limited to coastal patrol duties. The concept proved fundamentally flawed. The ferry battle represented a different kind of design failure. When it first flew in 1936, the aircraft appeared modern and efficient. This single-engine light bomber featured clean aerodynamic lines and a powerful Rolls-Royce Merlin engine. Designers expected the aircraft to conduct fast, low-level bombing attacks. Unfortunately, fighter aircraft technology advanced rapidly before the battle saw combat. By 1939, it was already vulnerable. Defensive armament remained extremely limited. During the German invasion of France in 1940, many ferry battles were destroyed by enemy fighters and anti-aircraft fire. Losses became extremely heavy during early missions. Another British aircraft reflected flawed pre-war combat theory. The Bolton-Paul Defiant entered service in 1939 as a turret fighter similar to the Blackburn Roc. Instead of forward guns, the aircraft carried a rotating turret equipped with 4 machine guns. Early encounters with German fighters initially produced surprising success. Enemy pilots mistook the aircraft for conventional fighters and attacked from behind. Once German pilots understood the design, the situation changed quickly. The Defiant lacked forward armament and struggled in head-on combat. Enemy fighters attacked from below or ahead. The aircraft soon transitioned to night fighter roles. The Blackburn Botha demonstrated the dangers of flawed aerodynamic design. Developed for coastal reconnaissance, the aircraft first flew in 1938. Designers intended it to perform torpedo attacks, reconnaissance flights, and light bombing missions. However, the finished aircraft displayed serious handling problems. Pilots reported poor cockpit visibility and sluggish flight controls. Stability problems made the aircraft difficult to operate safely. Performance also fell far below expectations. Training units soon experienced frequent accidents. Many crews considered the aircraft unsafe even during routine missions. The Royal Air Force withdrew the Botha from frontline service within a short time. The Douglas TBD Devastator initially represented a technological breakthrough for the United States Navy. Introduced in 1937, it became the Navy's first all-metal monoplane torpedo bomber with folding wings for carrier operations. The aircraft offered long-range and modern navigation equipment. Early evaluations praised its smooth flight characteristics. However, aviation technology advanced rapidly before the aircraft faced major combat. By 1942, the Devastator had become slow and poorly defended. During the Battle of Midway, Devastator squadrons launched torpedo attacks against Japanese carriers. Almost all aircraft were destroyed by fighters and anti-aircraft fire. The losses demonstrated the aircraft's growing obsolescence. The Curtiss SB-2C Helldiver was designed as a successor to the successful SBD Dauntless dive bomber. Engineers envisioned a faster aircraft carrying a larger bomb load. Early prototypes flew in 1940 and appeared promising on paper. However, the design suffered from severe structural and handling issues. Test pilots reported poor stability and dangerous stall behavior. The tail structure proved weak during early testing. The U.S. Navy demanded extensive redesign before accepting the aircraft. Even early production versions remained unpopular among many pilots. Later improvements eventually made the aircraft effective, but its troubled development became well known in naval aviation history. The Bell P-39 era Cobra represented one of the most unusual fighter designs of the Second World War. First flown in 1938, the aircraft placed its engine behind the pilot, driving the propeller through a long shaft beneath the cockpit. This layout allowed heavy nose-mounted cannon armament and excellent forward firepower. On paper, the design appeared innovative and heavily armed. However, the aircraft lacked a turbo supercharger after early redesigns. As a result, high-altitude performance suffered badly. In European combat conditions, the Airacobra struggled against German fighters operating at higher altitudes. Although it performed better in low-altitude combat with Soviet forces, the aircraft never matched its original expectations. The Messerschmitt Me 210 was intended to replace the successful Bf 110 heavy fighter. Development began in the late 1930s, and the aircraft promised improved speed, stronger armament, and better versatility. Its sleek fuselage and powerful engines suggested excellent performance. Yet the aircraft soon revealed serious aerodynamic flaws. Test pilots reported dangerous instability during flight. The aircraft often entered sudden spins that were difficult to recover from. Production continued despite these problems, but operational units experienced accidents and poor combat performance. Eventually, the design required major redesign work, leading to the improved Me-410. The Me-210 remains one of Germany's most problematic wartime aircraft. Germany's Heinkel He-177 Greif heavy bomber looked impressive on paper. Designed to deliver long-range strategic bombing capability, it featured a sleek design and high payload capacity. Engineers attempted to reduce drag by pairing two engines in each nacelle, driving a single propeller. This unusual arrangement effectively created 4 engines within 2 propeller systems. Unfortunately, the complex engine configuration caused severe overheating problems. Engine fires became frequent during operations. Maintenance crews struggled constantly to keep the aircraft operational. Although the bomber eventually saw combat, its mechanical issues severely limited effectiveness. The design remains notorious for its unreliable propulsion system. The Blackburn firebrand emerged as a powerful British carrier-based strike fighter concept during the Second World War. designers planned a fast aircraft capable of both fighter combat and torpedo attacks. The Firebrand featured a large radial engine and heavy armament. However, development delays and design compromises quickly appeared. The aircraft became heavy and difficult to control during carrier landings. Its handling characteristics frustrated many pilots. Performance also failed to match expectations for a modern naval fighter. By the time it entered service in the mid-1940s, more capable aircraft were already available. The Firebrand ultimately served mainly as a torpedo strike aircraft rather than a fighter. The Saunders Roe SR.A/1 represented an ambitious attempt to create a jet-powered flying boat fighter. Development began during the final years of the Second World War. Engineers envisioned a jet interceptor capable of operating from remote water bases without conventional runways. The aircraft featured sleek twin-jet engines mounted above the wing roots to reduce water spray ingestion. Early test flights demonstrated promising performance. However, rapid improvements in conventional jet aircraft soon made the concept less attractive. Land-based jet fighters achieved higher speeds and easier maintenance. The SR.A/1 never entered production. The project quietly ended as naval aviation moved toward carrier-based jet fighters. The Vought F7U Cutlass stood out as one of the most radical naval jet fighters of the early Cold War period. Introduced in the early 1950s, the aircraft featured a distinctive tailless design with swept wings and twin vertical stabilizers. Engineers hoped the configuration would improve high-speed performance and reduce drag. In reality, the aircraft suffered from weak engines and complex flight control problems. Carrier operations proved particularly dangerous. The aircraft experienced numerous accidents during its short service life. Maintenance crews also struggled with hydraulic failures and landing gear issues. Although visually striking, the Cutlass became known for its operational difficulties. The Convair F102 Delta Dagger was originally designed as a supersonic interceptor capable of defending North American airspace. Early prototypes first flew in the early 1950s with a sleek delta wing configuration. However, the aircraft initially failed to reach supersonic speeds during testing. Engineers discovered that aerodynamic drag from the fuselage shape prevented the aircraft from achieving its design goals. The solution required a major redesign using the newly developed area rule fuselage concept. After extensive modification, the aircraft finally reached supersonic performance. The early development struggles of the F102 became a major lesson in modern supersonic aerodynamics. The Lockheed F-104 Starfighter entered service in the late 1950s as one of the fastest jet fighters of its era. Designed around a powerful engine and extremely small wings, the aircraft achieved remarkable speed and climb performance. On paper, the design promised a revolutionary high-speed interceptor. However, the aircraft's tiny wings created very high landing speeds and unforgiving flight characteristics. Early versions also lacked advanced stability systems. Several air forces experienced high accident rates during early service years. In some countries, the aircraft gained an unfortunate reputation among pilots. Although later upgrades improved safety, the Starfighter's demanding design remained controversial. The Yakovlev Yak-38 Forger represented the Soviet Union's first operational vertical takeoff jet fighter. Developed during the 1970s for the Kiev-class aircraft carriers, the aircraft used a combination of a main engine and two lift jets for vertical flight. The concept appeared similar to Western vertical takeoff aircraft like the Harrier. However, the Yak-38 suffered from limited range and payload capacity. Much of its engine power was consumed simply maintaining vertical flight. Hot weather conditions further reduced performance. In combat roles, the aircraft carried relatively light weapons loads. Although it entered service with Soviet naval aviation, its operational capabilities remained limited. The Mikoyan-Gurevich MiG-23 introduced variable sweep wing technology into Soviet fighter design. The aircraft first entered service in the early 1970s and promised both high-speed interception and improved low-speed handling. On paper, the swing-wing configuration offered excellent flexibility across different flight regimes. However, early variants revealed several engineering and operational issues. The aircraft proved difficult to maintain and required complex mechanical systems for wing movement. Early radar and avionics systems also struggled with reliability. Pilot training demanded considerable skill to operate the aircraft effectively. Later upgrades improved performance, but early MiG-23 models never fully matched their ambitious design goals. The McDonnell X F-85 Goblin represented one of the most unusual fighter concepts ever tested. Developed in the late 1940s, the tiny aircraft was designed as a parasite fighter carried inside the bomb bay of large strategic bombers. The idea was to deploy the fighter during escort missions where conventional fighters lacked range. The XF-85 featured a compact fuselage and folding wings to fit inside the bomber. However, mid-air docking proved extremely difficult. Turbulence behind the bomber made the recovery process dangerous for pilots. Several test attempts nearly ended in disaster. The concept was eventually abandoned as aerial refueling technology improved. The Rockwell XF-V12 attempted to create a new generation of vertical takeoff supersonic fighter aircraft during the 1970s. Engineers proposed a complex thrust-augmented wing system that redirected engine exhaust through special wing surfaces. In theory, this design would allow vertical takeoff while maintaining high-speed fighter performance. The concept looked impressive in design studies. Unfortunately, the propulsion system never produced enough lift to support vertical flight. Testing revealed severe efficiency losses in the thrust augmentation system. Despite years of development work, the aircraft never achieved free vertical flight. The ambitious project ended without reaching operational capability. The BACT-SR-2 was one of the most advanced strike aircraft projects of the 1960s. Designed in Britain, the aircraft aimed to deliver low-level supersonic strike capability with advanced navigation systems. Its sleek design promised long range, high speed, and precise nuclear strike capability. Early test flights showed impressive performance. However, the project faced severe cost overruns and political pressure. Development complexity increased rapidly as advanced avionics systems required constant refinement. In 1965, the British government cancelled the program despite promising flight results. The TSR-2 remains one of the most famous cancelled aircraft projects in aviation history. The Convair B-58 Hustler became the world's first operational supersonic bomber when it entered service in 1960. The aircraft used a sleek delta-wing design and powerful engines to achieve remarkable speed. On paper, its ability to fly at Mach 2 offered significant advantages for penetrating enemy airspace. However, the design introduced serious operational challenges. The aircraft required extremely complex maintenance procedures. Operating costs became very high compared to other bombers. Its range also depended heavily on external fuel pods. As missile technology advanced, the role of high-speed bombers became less relevant. The B-58 served only a relatively short operational career. The BAD 152 represented East Germany's ambitious attempt to enter the jet airliner industry during the Cold War. Developed in the 1950s by former German aerospace engineers working under Soviet supervision, the aircraft featured a sleek, swept-wing design and jet engines mounted in pods beneath the wings. On paper, the aircraft promised to place East Germany among the world's advanced aviation manufacturers. However, the project faced major technical and economic challenges. During a 1959 test flight, the prototype crashed, killing its crew. Development problems and political pressures soon ended the program. The BAD 152 never entered operational service. The Lippisch P-13A was one of the most unusual interceptor concepts proposed during the final years of the Second World War. Designed by German engineer Alexander Lippisch, the aircraft featured a ramjet engine powered by coal, rather than conventional liquid fuel. The design used a sharply swept delta wing to achieve high-speed flight. On paper, the aircraft promised impressive performance using materials available during wartime shortages. However, ramjet engines require high initial speeds to operate effectively. Launching the aircraft into stable ramjet flight presented serious technical challenges. The project never progressed beyond wind tunnel models and experimental gliders. The McDonnell Douglas A-12 Avenger II was intended to become the United States Navy's next-generation stealth attack aircraft during the late Cold War. The design featured a flying wing configuration optimized for low radar visibility and long-range precision strike missions. Early concept drawings suggested a revolutionary leap in naval aviation capability. However, the aircraft's advanced materials and avionics proved extremely complex to develop. Costs rose rapidly as engineers struggled to meet performance requirements. Weight growth also threatened carrier compatibility. In 1991, the United States Department of Defense canceled the program after billions of dollars had already been spent. The Saunders-Roe Princess was designed as one of the largest flying boats ever constructed. Developed in Britain during the late 1940s, the aircraft aimed to serve long-distance, transoceanic passenger routes. The enormous aircraft featured 10 turboprop engines and a massive double-deck passenger cabin. On paper, the Princess promised luxurious long-range travel across oceans where airports were limited. However, the rapid expansion of land-based jet airliners soon made flying boats obsolete. Airports capable of handling large aircraft spread quickly around the world. Despite impressive engineering, the Princess never entered commercial airline service. The Caproni CA-60 Novaplano stands as one of the most extraordinary experimental aircraft ever attempted. Built in Italy in the early 1920s, the aircraft was designed as a giant transatlantic passenger flying boat. Its structure featured 9 stacked wings arranged in 3 triplane sets along the fuselage. 8 engines powered the enormous airframe. Designers believed the large wing area would allow stable, long-distance flight over oceans. However, the aircraft's unusual configuration proved extremely unstable. During its second test flight in 1921, the massive aircraft crashed into Lake Maggiore and broke apart. The ambitious concept ended almost immediately. The McDonnell XF-88 Voodoo prototype emerged during the early Cold War as a long-range jet escort fighter concept. Developed in the late 1940s, the aircraft was designed to escort American strategic bombers deep into enemy territory. The sleek twin-engine design demonstrated respectable speed and range during testing. However, the rapid development of aerial refueling and improved interceptor aircraft changed military priorities. Long-range escort fighters became less necessary for bomber protection. The XF-88 never entered production, though its design later influenced the development of the F-101 Voodoo fighter. Northrop Tacit Blue represented a secret experimental aircraft developed during the 1980s to test advanced stealth technology and battlefield surveillance radar. The aircraft featured a highly unusual curved fuselage designed to reduce radar reflections. Its bulbous shape looked unlike most conventional aircraft. On paper, the program aimed to explore new methods of combining stealth with ground surveillance capability. The aircraft flew numerous successful test missions. However, it was never intended for operational service. Instead, Tacit Blue served as a technology demonstrator. The research directly contributed to later stealth aircraft designs developed by the United States. Throughout aviation history, Many aircraft that appeared brilliant in early design stages ultimately revealed serious flaws once tested in reality. Engineering challenges often emerged only during flight testing or operational service. Some problems involved aerodynamics, while others stemmed from propulsion systems, maintenance complexity, or unrealistic mission requirements. These experiences forced designers to refine their understanding of aircraft performance and reliability. Failures often became stepping stones toward better technology. Lessons learned from flawed aircraft frequently influenced later successful designs that solved the same challenges with improved engineering approaches. The story of aviation progress is therefore not only about legendary aircraft that dominated the skies. It is also about ambitious experiments that struggled or failed. Each flawed design revealed important truths about aerodynamics, propulsion, materials, and operational strategy. Engineers learned to balance innovation with practicality. Military planners learned that revolutionary ideas must survive real-world testing before they can reshape warfare. The aircraft examined in this history may not have achieved lasting success, but they played a crucial role in advancing aviation knowledge and shaping the technologies that followed.